Hi, my name is Shannon Holliday, and I'd like to introduce this article. Receptor activator of nuclear factor kappa B, RANK, is enriched in CD9-positive extracellular vesicles released by osteoclasts. A few years ago, we found that osteoclasts released extracellular vesicles that contain RANK. And then a couple of years after that, Ikabuchi and colleagues expanded on our initial finding. So why is this interesting? Since the late 1990s, it has been known that the regulation of bone remodeling involves centrally proteins RANK-Ligand, RANK, and osteoprotegrin. RANK-Ligand is found in osteoblasts, osteocytes, some immune cells. And when it binds to RANK, which is a transmembrane protein on osteoclasts, it stimulates a signaling pathway which is required for both osteoclast formation and for bone resorption. Now, the protein osteoprotegrin binds to RANK-Ligand and is a competitive inhibitor of the RANK-Ligand-RANK interaction. It acts like RANK without the transmembrane domain. So we found that osteoclasts released extracellular vesicles that were rich in RANK. And we showed data to suggest that these RANK extracellular vesicles would inhibit the interaction between RANK-Ligand and RANK and reduce osteoclast formation. And we hypothesized that they was acting like osteoprotegrin. Now, Ikabuchi and colleagues found that it was far more than that. When the RANK extracellular vesicles interacted with RANK-Ligand on osteoblasts, it stimulated a RANK-Ligand reverse signaling pathway, which promoted bone formation. So with these RANK extracellular vesicles, you have an agent that can simultaneously inhibit bone resorption and stimulate bone formation, something that's potentially a very promising therapeutic. And indeed, Ikabuchi et al. Showed that they could make an anti-RANK-Ligand antibody that would mimic the RANK extracellular vesicles. So it seems like a really good deal. But there is what's happened with romosozumab. Now, this is a therapeutic that's on the market. It's a humanized monoclonal antibody that stimulates bone formation, but in a way different from the RANK-Ligand-RANK. But it is very good at promoting bone formation. There's three significant problems. First of all, it stimulates bone formation in places where you don't really want it, like the inside of the skull. This can lead to normal pressure hydrocephalus. And there are other issues. And for those reasons, you can only use this for maybe a year. Even though you're increasing the bone mineral density dramatically, it doesn't strengthen the bone as much as you really expect. And when you withdraw from romosozumab, it leads to very rapid bone loss. And so you get rid of all the bone that you have gained under the romosozumab treatment. And so the problem seems to be that when you deliver this systemically, you're just adding bone wherever. There isn't any specific location. Whereas in normal bone remodeling, you are building bone to react to what the bone needs. And so you're also strengthening bone. So is there any way around that? Is there a way to locally trigger the increased bone formation, kind of like you would in a young person? Now, we knew that in the osteoclasts, when they release extracellular vesicles, only a very small percentage, maybe 1 in 35, contains RANK. And the ones that do contain RANK have a lot of RANK. So there seems to be some specific way of packaging the RANK into extracellular vesicles. Maybe we could stimulate the osteoclast to produce more of these. But to do this, we have to have more knowledge of the pathway by which RANK is packaged into the extracellular vesicles. And by doing that, we could stimulate that pathway and then have localized bone formation. So in this study, we've sought to begin to address this by using single particle interferometric reflectance imaging sensor and also immunomagnetic affinity isolation. So what we found was that RANK is restricted, is highly enriched in CD9 EVs, but not CD81. And so this is a small step, but it's a step that says that RANK is packaged in a specific pathway. And so the idea of promoting that specific pathway to increase RANK production is one that's viable. This is the team that worked on on this project. Xiaobo Ruan, who worked in Mei He's lab, who is the primary ExoView person. Wellington Rohde is a longtime collaborator. Giovanni Patel, Lena, and Macy are undergraduate volunteers in my lab, and Lorraine was a visiting graduate student. George and Leaf helped with the ExoView project, and Mehi and I are the co-corresponding authors. And I hope you enjoy this article, and thank you for your attention.